Lesson 2 of complex numbers. Complex numbers in polar form. The learning outcome for this lesson is find the modulus and argument of a complex number in Cartesian form and express the complex number in polar form. The lesson today we are emphasizing to 4 important points. First one, Argand diagram. A complex number x equal to iy can be represented geometrically by a point in Argand diagram, where the real part represented by x-axis and the imaginary part is represented by y-axis. And the second point is modulus. The modulus of a complex number z equal to the length of the segment, so equal to square root x squared plus y squared. And the third point is calculate the argument z that is equal to arctangent y over x. The units is radians. The final point is polar. We represented the complex number in polar form. Z equal to R brackets cos theta plus I sin theta. The theta in unit radian. Modulus and argument. A point P, X, Y represent the complex number Z equal to X plus IY in Argand diagram. Segment line OP equal to R and theta measure from the line positive x-axis. So from the diagram we can see the real axis is at the x-axis and the imaginary axis is y-axis. And the segment OP is represented by R. That is the modulus of the complex number Z. They calculate by square root x squared plus y squared. And the theta calculate from the positive x-axis or real axis. That is argument z equal to arctangent y over x. The argument z is a unit value radian, so it's in between in the range negative pi and pi, and we call it the principal value of argument z. Principal argument of a complex number lies in the range of negative pi and pi in unit radian. So we can see very clear at the diagram. At the first quadrant there's a theta. The second quadrant we use the formula pi minus theta, and the third quadrant the principal is negative bracket pi negative theta, and the fourth quadrant is negative theta. The principal argument, first quadrant, sin theta and the cos theta are positive, so the theta is equal to A radian. Second quadrant, sin theta is positive, cos theta negative value, so the theta equal to pi negative A radian. And the third quadrant, sin theta negative, cos theta also negative, so theta equal to negative pi plus A radian. And fourth quadrant, sin theta negative and cos theta positive, so theta equal to negative A radian. There is all the principal arguments must be followed to get the argument of a complex number. Find the modulus and argument. Using formula modulus z equal to square root x squared plus y squared, and the argument z equal to arctangent y over x. Now we are going to finding the modulus and argument of complete number z equal to 4 plus 3i. By using the formula modulus z equal to square root x squared plus y squared, so the modulus z equal to square root 4 squared plus 3 squared equal to 5. To find the argument z, we must refer to the Argand diagram. So the complete number z at the point P is at the first quadrant. So argument z equal to arctangent 3 over 4 equal to 0.6435 radian. Finding the modulus and argument of complete number w equal to 5i. We can see very clear the complete number w, the real part equal to 0 and the imaginary part equal to 5. So the modulus w equal to square root 0 square plus 5 square equal to 5. And to find the argument w, that is equal to arctangent y over x. So we obtain arctangent 5 over 0. 5 over 0 is undefined. So we need to draw a sketch to obtain the angle to find the argument w equal to pi over 2 radian. Given a complex number z equal to -1 plus I. So find the modulus and argument of the complex number z. We can see very clear that the real part equal to -1 and the imaginary part equal to 1. So the modulus z equal to square root -1 square plus 1 square. So after do the calculation, we get modulus z equal to square root 2. Arctangent -1 can be at the second quadrant or fourth quadrant. Therefore, it is important to locate the point at the Argand diagram to make the decision. So after we locate the point for the complex number z -1 plus I at the Argand diagram, it is at the second quadrant. So by using the principal argument, at the second quadrant, sin theta is positive and cos theta is negative. So the argument z equal to pi minus arctangent -1. So after do the calculation, we have 3 over 4 pi radian. A complex number w equal to -1, -3i is given. Find the modulus and argument of complex number w. By using the formula modulus w equal to square root x squared plus y squared. From the information given, we can see very clear the real part is equal to -1 and the imaginary part is equal to -3. Therefore, the modulus w equal to square root -1 square plus bracket -3 square. After do the calculation, we obtain the modulus w equal to 2. We allocate the complex number w as a point at the Argand diagram. It is at the third quadrant. So according to the principal argument at the third quadrant equal to -pi plus arctangent y over x. Argument w equal to -pi plus arctangent -3 over -1. That's equal to -3. From the calculator, we obtain arctangent -3 equal to pi over 3. So we have negative pi plus pi over 3 radian. So finally we get the solution equal to negative 2 over 3 pi radian. A complex number can be written into polar form like r bracket cos theta plus I sin theta, where r is modulus of complex number z and theta is argument z and equal to arctangent y over x, where the range of the theta is in between negative pi and pi. Express the complex number z equal to negative 1 plus 2i in polar form. The first step solution, we have to find the modulus. The modulus for the complex number z equal to square root x squared plus y squared. So for the real part is negative 1 and the imaginary part is equal to 2. So the modulus of the complex number z equal to square root negative 1 square plus 2 square equal to square root 5. The next step solution, we have to find the argument. The argument equal to arctangent y over x. That is equal to pi minus 1.107 radian, followed by the principle of the argument. So the argument z equal to 2.035 radian. Next, we will rewrite the complex number into the polar form. So negative 1 plus 2i equal to square root 5 bracket cos 2.035 plus I sin 2.035.